My name is Erin Peterson, and I'll be introducing you to Overwatch, a distributed machine vision inferencing serving software. I'll be touching on the use cases and barriers to adopting machine vision before describing the capabilities of the software and demonstrating two applications that have been built for airlines and airport authorities with technology partners. While the use cases of machine vision are endless, some that have proven beneficial to this industry are environmental monitoring, security monitoring, people and facial detection, vehicle detection, as well as object detection and tracking. The current state of use of machine vision in industry is limited by some key factors. Currently, purchasing compute from the cloud for consistent inferencing is inhibitively expensive, and the learning curve to implement the cloud is not insignificant. Regardless of these barriers, if a company has restrictions on data leaving their firewall, the cloud as a resource for compute and storage is a non-starter. Our solution aims to tackle the clear dichotomy between those who can afford to innovate and those who are left without compute. Overwatch provides the backend for a machine learning inferencing serving software, which consists of the Overwatch server, the input server, and the model registry. Each communicate with the distributed compute and the client. To use a machine vision model on Overwatch, it must first be added to the model registry with a post request. You will upload it in Onyx format, as well as have the ability to add the corresponding pre- and post-processing in JavaScript or Python, which will be run on each input. You will also give the model an ID, which will be referenced each time that you use the model, indicate the packages that are needed for the pre- and post-processing, and decide on a password that will be needed to edit or delete the model. To perform inferences using the model that you have added to the model registry, all that is necessary is to make a post request to the Overwatch server. This post request consists of an authentication key, the ID that you assign the model, and the inputs that you would like to perform inference on. You can also indicate the project ID and the batch size, which is how many instances of input will be sent to each worker. Compute is powered by Distributive, offering a secure distributed computing protocol over the web. Compute can be offered and used in one of three ways: on the browser for testing, in a Docker for Unix, or on a screensaver for Windows computers. An enterprise implementation of Overwatch allows for computers on the premise to be utilized for compute when they are idle, providing compute power inside your firewall. Your workers will also be registered in a compute group, ensuring that both the compute and data stay internal and in their specified areas. I'm now going to give a demonstration of Overwatch performing two different jobs. The first use case uses a model that detects airplanes, forklifts, people, gates, and fences to determine their interactions, as well as to determine the speeds of the forklifts, so it can provide alerts when thresholds are surpassed. The second is an example of a face detection model, which demonstrates the capability of facial blurring for CCTV video feeds requested by an airport authority. I'll be using Google Colab and a browser worker for simplicity, but Overwatch can be used with any programming language with a simple RESTful call. Due to differences in computational requirements, I'll be sending 4 images to 2 workers for the forklift model and 200 images to 2 workers for the face detection model. As you can see, I'm sending a post request for each, and I'm specifying the same compute group, which this worker is a part of. I'm also specifying the number of images per worker, as well as the project ID that, as you can see here, appears in the progress bar to indicate how far along the job is. While this URL is going through the public network, if a solution was to be deployed on-premise, it would be swapped out with your IP address so that no data would leave your firewall or be reachable from outside. As you can see here, results are returned from the worker, and they're in the format that was specified in the post process that was associated with the model. In this case, we have bounding box coordinates as well as their corresponding confidence scores. These results can be easily manipulated to provide insight into the images, which I'm going to show a basic example of here, blurring the detected faces and visualizing bounding box in the airport hangar. The real benefit comes when these results are used to increase security and inform business decisions. These use case specific solutions can be facilitated with a front end designed by yourselves or a solution provider. Thank you so much for taking the time, and please feel free to reach out if you have any questions.